Modern cities are changing fast. Every year, more people move in, bringing their cars, bikes, and buses with them. Streets fill up with traffic. The daily rush hour becomes a test of patience for everyone. Old road systems can't always keep up with the number of vehicles. City planners around the world search for solutions to help people move more easily. Sometimes widening roads just isn't possible because buildings and businesses fill every space. So, engineers look up. They build roads above other roads, called flyovers, to ease traffic jams and keep cities flowing. Flyovers have become a symbol of progress in places like Mumbai, London, and Los Angeles. They help connect neighborhoods, make commutes shorter, and boost city life. But building these huge structures in the middle of busy cities isn't easy. The process takes careful planning and lots of hard work. In this essay, we'll look at how modern flyovers are built, step by step, and why it's such an amazing feat of engineering. A flyover is a raised road or bridge that lets traffic pass over other roads, railways, or obstacles. Think of it as a shortcut in the sky for cars and buses. Unlike big bridges that cross rivers or valleys, flyovers go over busy city streets. Their main job is to separate traffic streams and remove bottlenecks. Building flyovers in cities isn't the same as making bridges in open areas. Space is tight. There are buildings, power lines, water pipes, and people everywhere. Engineers must fit their designs into crowded neighborhoods without causing chaos below. Another challenge is city life itself. Roads can't be closed for months at a time. Commuters, delivery trucks, and emergency vehicles all need to keep moving. So construction teams must work in stages and often at night to avoid shutting down busy roads. Cities like Bangkok and Jakarta have learned the hard way that a poorly planned flyover can cause more problems than it solves. That's why careful design and community involvement are so important. A good flyover blends into the city and improves life for everyone. Every strong flyover starts with a solid foundation. Before any concrete is poured, engineers must know what's under the ground. This is called a geotechnical investigation. Specialists drill holes and take soil samples to see how stable the earth is below the site. They're looking for soft clay, hard rock, or even old pipes and cables. Based on these tests, engineers decide what kind of foundation will be safest. Most flyovers use deep piles, long thick columns made of concrete or steel that are pushed or drilled deep into the ground. These piles carry the weight of the flyover above, spreading it safely into the earth. The work of installing piles is noisy and messy. Huge machines drive or bore the piles down, sometimes more than 20 meters deep. Workers must watch for underground surprises, like water lines or old building foundations, which can slow things down. Once the piles are set, the site is cleaned up and made safe. The city above keeps moving, but beneath the surface, the real backbone of the flyover is taking shape. With the piles buried deep underground, it's time to connect them at the surface. This is done with a pile cap, a thick slab of reinforced concrete that ties several piles together. The pile cap acts like a big, sturdy platform, spreading the load across all the piles beneath. Next, come the piers. These are the tall columns that hold the flyover high above the street. Piers are usually made of reinforced concrete, poured into large molds called formwork. They must be perfectly straight and strong enough to bear thousands of tons. Building a pier is a careful job. Workers set up steel frames and pour in concrete, layer by layer. Sensors and laser levels check that everything is in the right place. The shape of each pier is designed to withstand wind, earthquakes, and the steady thump of traffic above. Once the concrete hardens, the piers stand tall and silent, ready to lift the rest of the flyover into place. The city's daily life continues below, as these new columns rise up on the skyline. Now that the piers are up, it's time to add the next link, the pier cap. This is a wide, flat slab that sits on top of each pier, a bit like a hat. It spreads the weight of the road above and helps connect multiple piers together. Pier caps are made with strong steel bars and thick concrete. On top of the pier cap, engineers place special devices called bearings. Bearings are critical. They allow the heavy road structure above to move a little, expanding in the heat or shaking during an earthquake without breaking. There are different types of bearings, like rubber pads or sliding steel plates, chosen for each project. The precision needed here is intense. Each bearing must be lined up perfectly so that the flyover sits evenly. Even a small mistake can lead to big problems later on. Engineers use lasers and measuring tools to double-check every step. With pier caps and bearings in place, the structure is ready for the next big phase, lifting the main road into the air. The next challenge is building the main road, called the deck, high above the street. Engineers use huge beams called girders to support the deck. There are two main methods for this precast and segmental construction. Precast girders are made in a factory, then hauled to the site on trucks. Massive cranes lift them onto the bearings, sometimes at night when traffic is light. In segmental construction, smaller pieces are built on site and joined together, bit by bit, using special glue and steel cables. Once the girders are in place, workers build the deck slab. They set up forms, lay down steel bars, and pour concrete to make a wide, flat road. The deck slab must be strong enough to hold heavy trucks and stand up to rain, sun, and even earthquakes. This phase is dramatic. You'll see cranes lifting giant beams right over city streets and workers suspended high above the ground. It's risky work, but careful planning and teamwork keep everyone safe. Safety is a top priority for flyover engineers. Every stage of construction includes special features to protect drivers, pedestrians, and workers. Strong barriers line the edges of the deck, preventing cars from going over the side in case of an accident. Drainage systems are built into the deck to clear rainwater quickly, stopping puddles that could cause skidding. Expansion joints are added every few meters. These let the concrete stretch and shrink with changes in temperature so the road doesn't crack. Flyovers also need good lighting. Bright streetlights are installed to keep the road visible at night and in bad weather. In some cities, engineers add cameras and sensors to monitor traffic and alert emergency crews if something goes wrong. All these safety features are checked and tested before the flyover opens. They help make sure that the new road is not just fast, but also safe for everyone who uses it. Building a flyover in a city is like performing surgery while the patient is awake. Roads below must stay open, even as cranes and workers move above. Engineers use clever tricks to make this possible. First, they build in sections. Only small parts of the street are closed at a time. Construction often happens at night or on weekends when traffic is lighter. Temporary barriers and signs guide cars safely around the work. Sometimes engineers use launching girders, giant machines that slide new beams into place without blocking the road below. In cities like Singapore, these machines have made it possible to build flyovers right over busy highways, day and night. Communication is key. Signs, traffic updates, and even smartphone alerts keep drivers informed. This careful planning means city life can go on, even as the flyover grows above. Every stage of flyover construction is checked and double-checked. Inspectors test the strength of concrete, measure the alignment of beams, and watch for even tiny cracks. Modern technology, like drones, sensors, and computer models, helps spot problems early. Building a flyover is a team effort. Engineers, builders, city officials, and safety inspectors must all work together. Mistakes can be costly, so quality control is strict. If anything fails a test, it's fixed before moving on. The end result is more than just a road. It's a lifeline for the city. Flyovers keep traffic moving, connect neighborhoods, and support the growth of modern cities. They show what's possible with hard work, smart planning, and a bit of daring. So next time you drive over a new flyover, take a moment to admire the engineering and effort beneath your wheels. Building these giant roads in the sky is a complex job, but it's what keeps our cities alive and moving forward.